How are you? Stanisław Barszczak, I am. What outside the universe? There is an afternoon with me. I should start this interview with politics in Poland. Dear my country people, then tell about Zagłębie region in Poland, the places of my youth. But I don't know myself, so I will limit this interview to how I watch the stars. Dr. James Beecham is a particle physicist searching to answer to the biggest open questions of physics using the largest experiment ever, the Large Hadron Collider at CERN in Geneva. He hunts for dark matter, gravitons, quantum black holes, and dark photons as a member of the Atlas collaboration, one of the teams that discovered the Higgs boson in 2012. He ended the conference 2019 with a science class out this world and a reminder of that to physics. We all the same. He gave a lecture called What's Outside the Universe. This time I will tell you about it. What outside the universe? My friend gave me this question in Krakow when I was 18 years old. You can't live walking in the shade only. The Webb probe reaches as far into space as possible, and you can view stars and galaxies from 14 billion light years ago, at times of the earliest universe. We need a demonstration of the vastness of space. It is man-nature. Modern physics shows that space itself expands. Here I will tell about it. The Large Hadron Collider, LHC, that is the world's largest particle accelerator, located at the CERN European Nuclear Research Center near Geneva. LHC is located in France and Switzerland and is the largest machine in the world. Its essential elements are placed in a torus-shaped tunnel approximately 27 kilometers long, located 50 to 175 meters underground. The results of the collisions are recorded by two large elementary particle detectors, ATLAS and CMC, two smaller ones, ALICE and LHCb, and three small ones, TOTEM, LHCr, and MOIDER. From 2008, the device was supposed to collide two opposing beams of protons. The collision energy was to be 14 TeV. The main goal of the experiment conducted at the LHC is to better understand the elementary particles. In particular, physicists want to confirm or disprove the existence of the Higgs boson, confirmed in 2012. Dark matter particles, superpartners, higher dimensions, magnetic monopoly, and axion. Science confirms the thesis that if the cosmos were to shape differently, only on Earth insect caterpillars would be 5 meters larger than ours, Homo sapiens, if there was much more oxygen in the Earth's atmosphere, let's say. The predicted Higgs boson is in the CERN laboratory in Switzerland shows something new. In the Hadron Collider, the elementary particles of the world's matter are subjected to enormous acceleration to close to the speed of light of 300,000 kilometers per second. This is a huge speed. It shows that everything is possible in drawn proportion. Movement changes everything. I don't exaggerate. Here, both to us a special and general theory of relativity, the latter with the gravity of the universe. In the Higgs field, the particles of matter, the elements of the cosmos, assume mass and other properties that not only differently but always unexpectedly appear. And now, my house owners, what do I need from you? I would say strongly, will we see someday the multiplicity of worlds or our one universe? Contemporary science also notes the so-called escape of the galaxies starting from the so-called Big Bang. The latter is a result of the adoption of Einstein's theory of relativity. Why are galaxies running away faster than they should? Not everything follows Einstein's equation for the balance of energy and mass in the universe. See famous equation E equal mc squared. Now scientists are considering various and even smaller elements that Einstein did not know. Back then, however, his authority as a celebrity was enormous. The molecular corpuscular image of light prevailed. Louis Victor Pierre Raymond de Broglie, a French physicist, was awarded the Nobel Prize in 1929 for his discovery of the wave nature of particles. The world seemed to us still simple. The world has three final 4 dimensions. We did think. This is where the role of the observer comes into play. In Newtonian physics, we did not take into account whether the wave's observator remained in an inertial environment in relation to the phenomenon observed by the observer in motion. Still retains specific properties. In the multidimensional reality, the angles OSC, for example, C wave, passing through obstacles and such a propagating wave retain the specific properties, which in modern physics are described primarily by mathematical equations. To achieve Planck energy, one would have to build an atomic hadron collider and so on. We should live in a cosmos shaped for multiverse. There is an impressive task for us, for then we could become even smaller. Something very interesting is happening in the Planck era. The three-dimensional space-time collapses there as if there was no time, but there is always hope, though black holes in gravitational waves go crazy. In the quantum theory of the universe, in the microcosmic look at what surrounds us, we begin to admire the energy regime of the cosmos and the so-called possible multiverse described by the Higgs mass. Everything is inconstant. It is not us, we would say here. We will keep the possibility, happiness, the chance to describe the universe in the future. Einstein wrote about space-time, but he also described the so-called absolute time. Now scientists take into account different and even smaller elements they didn't introduce by Einstein in the description of reality, including the angle of propagation of a wave of light, emphasis of mine. These scientists are not talking about 5 Einstein mistakes, about it another occasion. Time after 1924 could have curved space-time differently and from a different point of view, I will say. As I said, movement in the theory of relativity is very important, and from the general theory of relativity we get new elements for the description of the cosmos, significant features of gravity. So will we see someday the multiplicity of worlds or our one universe? At the end of the day, I realize by looking at the sky that there is at least one universe above me, and still stars and galaxies are staring at us from very far away. Thank you for your cooperation.